Good morning, good afternoon, or good evening. This is a full paper work through of the January 2024 mock paper for A level. The intent of this is twofold. One is to see a relatively blind work through. Of course, I probably have seen all these questions before last year, but a relatively blind work through to hopefully give the ideas of the thought processes, the important things to be considering as you work through one of these papers. And secondly, to give you a resource to more effectively review your own mock. So you've got a model set of answers and the ideas for each question. Let's go for Mr. Cell, first name Ed, for our amusing name this time, and we'll jump straight into it. I will note that I do have my calculator ready to go on the side, and I am going to open up the formula book just in case I need it. Both of those will be available to you and should always be available to you as you do any of your own mock papers. So I've got those two things ready, so let's start. Straight in with our multiple choices. We have a graph, a quadratic, with roots shown in the picture. We want to find the set of values which satisfy that quadratic being positive. Well, the part of the quadratic which is positive are those two sections, so we need to describe those as inequalities. It's a strict inequality, so our answer needs to be strict. Well, that side's when x is greater than 5, that side's when x is less than 2. They're two separate branches, so I'm looking for the one which has two separate branches, which is that one there. Notice I did have to have the union, because I'm allowed to be in either branch, rather than the intersection, which would said I needed to be in both branches. I can't be in both branches at the same time. So that had to be my correct answer. Question 2. We've been given that the integral from 0 to 6 is that, the integral between 3 and 6 is that, so the integral between 0 and 3, well, this is a fun little fact that the integral from 0 to 6 is just the integral from 6 to 3 plus 0 to 3. So if that's 20 and that's negative 10, that final integral must be 30. One of the nice tricks you can do with splitting up an integral. The curve has that equation, find dy by dx. First thing I'm going to do is rewrite the original curve, particularly for the x to the power of a half, but I'm also going to write an eighth rather than over 8. So therefore my dy by dx, bring down the power, reduce the power by 1, that's now a power of 1, so I'm not going to write it. Bring down the power, the 4 gets halved to a 2, reduce the power by 1. 3 marks for that, quite generous, but it is early in the paper. The point P with those coordinates lies on the curve. Find the equation of the tangent at the point P. Okay, well, tangent means I need to find the gradient, so dy by dx at x equals 4 is my coordinate, so that's going to be a quarter of 4 plus 2 times 4 to the negative a half. Calculator is going to give me an answer there. Of course, you might be able to do some of these calculations mentally. Go for it, but I will always check with the calculator. That gave me a gradient of 2. So now y minus y1 equals m x minus x1. We already know that m is 2, y1 and x1 are the 10 and the 4. Now, because the question just said that, I can leave my answer as so. I'm always in the habit of expanding out just to make it look cleaner. And before I move on, a little mental check. Does that point there lie on my curve? If I sub 4 in as x, 2 times 4 plus 2 does give me the y coordinate of 10. So I can give myself a pat on the back there that at least looks correct. 3c, show the curve has no stationary points. Well, the fact that we need to remember here is stationary points occur when the dy by dx equals 0, i.e., what was it, 4? A quarter x plus 2x then minus a half equals 0. So I'm going to try and work out whether or not this has any solutions. Well, that's not immediately obvious. Let's multiply by 4. And I'm going to move that term to the other side. I'll multiply up by that negative power. And if I cube root, that's saying the square root of x is negative 2. And then that has no solutions, as you can't square root. As the square root of something is always positive when written with just the square root symbol. It implies a positive square root. If I did put x equals 4 in, yeah, and you can see that if the only solution that this would give would be x equals 4, if I were to square both sides, but if I were to sub x equals 4 into this thing, I get an answer of 2, not the answer of 0 that I wanted. So really actually quite a subtle argument there to really acknowledge why that has no solutions. And of course you could probably get the x equals 4 and check it that way. Question 4. Zayad is training to become a long distance swimmer. He trains every day. The length is 25 meters. I'm already feeling like this is going to be some kind of series question. Each day he increases by 4. On his first day he swims 10 lengths. Write down the expression he'll swim on the nth day. This formula is not given, but hopefully you remember it by now. A equals n minus 1d. So our first term was 10 on the first day, plus n minus 1 lots of each day increases by 4. I am going to expand that out, 4n plus 6. And that does match the, when n equals 1, we do get the 10. A good little check there as well. Zayad's target is to be able to swim at least 3,000 meters in one day. That's quite a large number because we only started with 10 and we're only increasing by 4 each time. But if he wants to go for at least that, well, let's try and solve the nth term equal to that. So on which day number will he reach there? So 4n is 2994, n is 748.5. So on the 748.5th day, he would reach that. Of course, he can't have a 0.5th day, so that means we're going to have 749 days will be his minimum. And on that day, he'll then swim 3,002 meters. He won't hit it exactly. And for 3 marks, that seems reasonable. For the amount of work we've done, that's maybe a bit generous. Zayad's coach claims that when he reaches his target, he would have covered a total distance of over 50,000 meters. So what we're asking now for is the sum over those 749 days. Well, the summation formula is given is your n over 2, 2a plus n minus 1 d. I'm always going to write that out for the examiner at least once, so they know that I'm not just pulling a number out of nowhere. And typing that into my calculator gives me a ridiculously large number. 1 1,127,994. Now I am a little worried for the reason that number seems so far away from the 50,000 in the question. And that automatically gives me alarm bells. So I would like at this point to check previous parts of the working. Make sure I haven't done something a bit silly. And yes, I have. I've misread the question right at the beginning. So this is a really useful exam technique. That number's ridiculous. What have I done potentially wrong? And I didn't read the question carefully enough. He didn't swim 10 meters, he swam 10 lengths. And well done to anyone who's probably shouting at the screen for that mistake straight away. So, swim 10 lengths, well, that is 250 meters. And then we're increasing the number of lengths by 4. And I'm now reading the question properly. It's not asking for the distance, it's asking for the number of lengths. So that is correct for part A. I just didn't acknowledge what it was talking about. For part B, however, we're traveling 3,000 meters. Well, the number of lengths is that 3,000 meters divided by 25, because each length was 25 meters. So I'm actually only going for 120, which now looks much, much more reasonable. The 120, subtract the 6, divided by the 4, means it's 28.5 days, which now is a much more reasonable target, and it's going to take in 29 days to reach that. And now I can correct the final part. We're not doing it for 700 days. That should have sent alarm bells to start with, and I should have checked at that point. We're now only going for 29 days. So let's put the correct numbers back into the formula. Of course, in a real exam, you'd just put a line through this, because you won't be able to erase it. So now in my calculator, I'm using the 29 over 2, 2a plus n minus 1d. So that's, should also make sure that that subscript's correct. That's 1,914 lengths. Now let's convert that back into meters. So he's going to have swam that times 25 is 47,850. Now that number looks like the question. So is Zayed's coach correct? No. Zayed's coach is not correct. Zayed swam less than. The aim was 50,000, so swam less than 50,000 meters. Okay. Hopefully, even though the mistake was there, that question showed how to spot your own mistakes. Question 5. Victoria Market Researcher believes the average weekly value of groceries has grown exponentially. We're expecting that model. And Victoria wishes to determine the values of A and B. She plots a log against n, draws the line of best fit. The equation of her line of best fit is that. Use the equation to show that 3 sig figs, A is 57.5. So this is a log-log plot. The first thing to either remember or derive is how these log plots are linked. If I start with the original, I take logs of both sides. And multiply means I can split it up. And a power means I can bring the power down in front. So that log base 10 of A is the y-intercept is 1.76. i.e. a is 10 to the power of 1.76, and 10 to that power is 57.543, etc. So a is 57.5 to 3 sig fig, which is exactly as the question requested. Part B, or part 2, use the equation line best fit to find the value of b. So again, let's look at my equation that or the memory of log-log plots. The b is the gradient, or log 10 of b is the gradient, so that's 0.057. So log base 10 of b is 0.057. So b is 10 to the power of that thing, 10 to the power of 0.057 is 1.14 to 3 sig fig. Part B, according to Victoria's model, state the yearly percentage increase in the weekly sales. Okay, so now we're comparing this V, which was 10, was it 10 to the power? No, B to the power 1.14 to the power of n. Yearly percentage increase, well, we're comparing this to a compound interest style formula. This should look very much like your GCSE compound interest, where you have the value is equal to the initial times the multiplier to the power of the number of years. So our multiplier is 1.14, and then we just need to interpret that as a percentage increase. So that's a 14% increase. Use the model to predict in 2025. Okay, I was just checking there wasn't any gap. Well, there are gaps in the table, but neither of those are the ones we wanted. So in 2025, what is the value of n? Well, is it not 16? Yeah, it's just 16, isn't it? Because we started in 2009. So we have n is 16. So our model is predicting times 1.14 to the power of 16, 57.5 times 1.14 to the power of 16. As the question throughout has told me 3 sig figs for each of the values, I'm not going to put more accuracy into this. And I'm also giving my answer to 3 sig fig, and then just double check units. V was in millions of pounds. Let's put the pounds. Millions. Explain why that prediction is unreliable. It's only a 1 mark, so I don't need to go into too much detail. And the point here is 2025 is outside the data set. Our data only went to 2016, I believe. It's outside the data set, so is extrapolation and potentially unreliable. You should always try and reword the question into your answer. Yeah, we only went up to 2016 with our data, so predicting all the way to 2025, another 9 years afterwards, no reason why this model or this pattern should continue in the way it has. Question 6, log equation. This is quite nice as a log equation goes. And when I say nice, I do mean quite unpleasant. Show that that equation has exactly one solution. Okay, the trick with log equations to start with is to get rid of the logs. Now, we can't get rid of the logs just by crossing them all out. That would be completely fictitious. So instead, oops, went back too far. our trick is to turn both sides into log of something. So the left hand side we can write as log of x squared. The number in front comes up as a power. And the right hand side, if you add two logs, you multiply on the inside. Now we have log of something equals log of something. Well, that just cancels. Now we can cross out these logs. What we've really done is done 10 to the power of both sides. And this is going to be a quadratic, so I'm going to subtract off, and I have my quadratic. Now, does that factorize? That looks like it factorizes. Now, I'm a little worried here because I only want one solution. But if I can see that this factorizes, that means I'm getting two. So let's believe for now and see what happens. This factorizes as so. I'm going to do a quick mental expansion to check it works. So either x equals 8 or -4. Okay. But that's two solutions. But the one thing to recognize is we can magic solutions out of nowhere when we solve log equations. So we always should check in the original. So normally this is just a mental check. We actually have to do this properly. So let's check in original. When x is 8, that's saying 2 log base 10 of 8 equals log base 10 of 4 plus log base 10 of 16. Left hand side is log of 64. Right hand side is log of 64. That one works. But if I check the x equals -4, I'm getting 2 log base 10 of we have log base of a negative number. Everything else worked out fine, but that section there is not allowed. It's undefined, which says that x is -4 is not a solution. So therefore, x equals 8 is the important thing is it's the only solution. A bit of a trick question there, because when you see exactly one solution, your mind should go to the discriminant b squared minus 4ac equals 0. We did get to a quadratic, but if you discriminated on that, you would have got something positive. So you wouldn't have been able to make the conclusion. And as I said, as we were going through the question, this looked like it could factorize, which was concerning, so I had to adjust my method on that. Question 7. Given n is a positive integer, express that as a single fraction, not involving surds. Okay. Well, this doesn't look as bad as it originally might. And that's because these two denominators are complex conjugates of one another. So when we do our common denominator, we are actively rationalizing both of them at the same time. So the first fraction, I'm going to times top and bottom by the 5 root 10 minus 3, the opposite of the denominator. So on the denominator, I've got 5 root 10 plus 3, 5 root 10 minus 3. I've written the denominator there in the opposite order, just to make it look more symmetric. And the other one, I'm timesing top and bottom by the other denominator. So that's a 5 root 10 minus 3, 5 root 10 plus 3. So the numerators, 35 root 10 minus 21 minus 35 root 10. Now I'm subtracting, so it's another minus 21. Yep, and the denominators are both going to be the same. I'm getting 25n. I'm going to write it out in full, although I do know that these middle terms are cancelling. On the numerator, the 35 root 10s disappear and I'm left with minus 42. On the denominator, the 15 root 10s disappear and I'm left with 25n minus 9. Now, my first thought on how to check this is, was I expecting this fraction to be negative? Well, if I look back to the original, I'm not really, am I? If I look back to the original, yes I am, because this denominator here is bigger than this denominator. So this fraction is smaller, divided by a bigger number, is smaller than this one. So I'm doing a smaller fraction, subtract a bigger fraction. So yes, I am expecting my answer to be negative. That looked a bit weird, so it's worth having that little mental check. Hence, deduce that that thing is rational for all positive values of n. Well, we've already got that this thing is equal to negative 42 over 25 minus n, which is rational. This is a fraction where the numerator and denominator are both integers, as we were told that n is an integer, which implies it is rational. Being rational simply means you can be written as a fraction with no nonsense involved, no extra powers, no roots of any form, no e's, pi's, etc. We don't have that here, we do just have the numbers themselves. Question 8, a show that integral. So here we need to decide on the technique. We have x sine 4x, two things multiplied together, which restricts ourselves to either substitution or by parts. Now the thing to notice is the thing on the outside is not the derivative of the thing on the inside, which kind of cuts out substitution, at least cuts out the simplest versions of substitution. So instinct here should be going to by parts. Now if you remember by parts, if you use the LATE acronym to tell you which order to pick things in, we should be picking u to be the x and the dv by dx to be the sine 4x. Reason being, when we differentiate and we integrate, the second integral that's going to pop up, I'm talking and writing at the same time and I'm writing weird things, the second integral is going to be a lot easier because the x is differentiated back down to 1. I'm going to go up here and just call this I, so I can say that I is now, integration by parts says uv, so that's going to be the negative a quarter x cos for x between the limits, minus the integral of u dash v, which is a negative quarter cos 4x. Again, I still need my limits. So I'm going to do the integral before I start subbing things in. If you want to sub stuff in at this step, you're more than welcome to. That's going to be a positive quarter, but when I integrate, I get another sixth sine 4x between the limits. And that's now become positive because I had negative, negative. If I do differentiate a 16th sine 4x, I do get back to the quarter cos x. As quiet now, I just need to sub some values in. Here we have negative a quarter times pi by 2. Cos of 4 times pi by 2 is cos of 2 pi. Cos of 2 pi is just 1. Minus, if I sub 0 in there, the x at the front is going to destroy it. Plus, now if I sub pi by 2 into sine of 4x, that's sine of 2 pi, which is 0, and sine of 0 is 0. So that comes out as negative pi by 8. This was a show that question. It was negative pi by 8. I'm sorted. Being a show that question, you can't cheat. You can't type this into your calculator, but you see that if you are a master at by parts, that's a very efficient 6 marks. Question 9. Functions. F and G are defined as so. H has a maximum possible domain is G of F. What am I allowed to put into that? Oh no, just find an expression for H first. I'm already doing part B. So H of X is G of whatever F was, which is 1 over the square root of 10 minus 2x. So now the domain, what am I allowed to put into that? Well, I have to have x being less than or equal to 5 to go into the denominator, but the denominator cannot be 0. Well, it's 0 when x equals 5, so the domain is when x is strictly less than 5. Anything else would cause a problem. Show that H inverse is that thing. So the trick here is to set y equals 1 over root, etc. I'm going to multiply up by the root, divide by the y, square both sides, 1 over y squared. I'm going to move the 2x over and the 1 over y squared back. And finally divide by 2, divide both sections by 2. Again, I've glanced back at the answer a couple of times to check that I'm aiming towards the right type of shape. Of course, I could have done things in a slightly different order and I would have got a different shape of answer. And then finally, F inverse of x is equal to that thing, but I need to replace the y's with x's. A lot of people replace the y and the x at the beginning. As long as you replace them at some point, it does not make a difference. That was the end of question 9. I was half expecting another part to that. That was quite a nice question then. Question 10. Given that cos is not equal to plus or minus 1, prove that identity. Okay, identity is almost always the best way to do it. Start with the more complicated side and try and rearrange to make it look like the simpler side. Here, the more complicated side is the double fraction. And straight away, I can common denominator this. Over the 1 minus cos theta, 1 plus cos theta, plus, and the equivalent for the other term. The denominators are difference of 2 squares. So my numerator, and I'm doing it slowly-ish, because it is a show that question. I can't skip too many steps, even though I would quite like to. So now the numerator simplifies to just 2, and the denominator, 1 minus cos squared, well that's just sine squared. And finally, the 1 over sine squared is exactly the cosine squared, which is the right-hand side, and we're done. Full marks there for that. Quite pleasant. Hence, find the set of values for a which that equation has real solutions. Well, hence is my favourite word within maths exams. Hence means reread the first part and use it. So the first part of the question is telling us that 2 cosec squared theta is equal to this a. Now we can answer it straight from here, but I'm trying to work out if it's nicer to turn things into sine or just to deal with cosec. I think it's just nicer to deal with cosec. We know the cosec graph does that kind of thing, where it's outside of minus 1 to 1. So when I square it, or when I square negative numbers, they become positive. So cosec squared is always greater than or equal to 1, which means 2 cosec squared is always greater than or equal to 2. So this has real solutions when A is greater than or equal to 2. Now you could have rearranged that to be sine. I think it'll just become a little less pleasant, and certainly because you'll end up doing a square root at some point and then you'll have to worry a little bit there. But I think that's the most efficient way to do that question. Part C. Given that theta is obtuse, that's actually quite important there. That's going to determine the sine. Find the exact value of cot. Well, again, this is still the same question, so I'm still going to use the previous parts of the question, which was that double fraction is equal to 2 cosec squared. Well, that's telling me that cosec squared is 8, or cosec is plus or minus, that was a very unpleasant looking 2, plus or minus 2 root 2. Okay. Well, I wanted cot, and back in my memory banks, there is a link between them. I remember that version. If we want the cosecs, we're dividing through by the sine squared. Cos over sine is exactly cot, and the other side is your cosec squared. So, cot squared is equal to cosec squared minus 1. I didn't actually need to square root the cosec, as it turns out. So that's 8 minus 1, that's 7. So cot theta is plus or minus root 7. And this is where the obtuseness comes in. If we think about the cot curve, well, that's difficult to think about. So I'm going to think about the tan curve first. The tan curve is as so, where that value there is your pi by 2 and your pi. So when you are obtuse, tan is negative. Well, if tan's negative, then cot, which is 1 over tan, is also negative. So my answer is cot theta equals negative root 7. Negative root 7. That's my final answer. And yeah, one other thing to notice in the question, it does say exact, so the desire to flip this over and tan inverse it to find the value of theta, to then put it back into 1 over tan to get the cot, would not give you an exact answer. So although that will give you an answer, it won't be exact, it won't get you the marks. Question 11. Find the first 3 terms in extended powers x of that binomial expansion. So that's 1 plus x to the negative a half. We want the first 3 terms. Well, that's quite nice. The first term is just 1. The second term is the power times the x thing. And the third term is the fanciest one. It's the n minus 1 over 2 times the x thing squared. Notice here the x is just an x. There's nothing fancy going on there. So now let's simplify it. The next term is going to be positive 3/8 x squared. I've lost my x there. I'm going to put plus dot 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 because I've used the equal sign. We do need those extra terms for it to actually be an equals. A student substitutes x equals 2 to find an approximation. Explain the mistake in the student's approach. Now, if you do sub x equals 2 into this, it does give you that thing. However, there is a restriction on the binomial expansion, which is stated in your formula booklet. And that is that this expansion is only valid sometimes. So here, the expansion is only valid for, and the formula booklet says mod x is less than 1, and 2 is not in this region. So 2 will not work. You cannot sub 2 in to find that. Part C has told us to sub a different thing in, subbed in negative quarter. Now negative quarter will work, because negative quarter, the modulus of, is less than 1, but it's not maybe as obvious to how this gives 1 over root 3. So let's first just sub it in and see what happens. So that's 1 minus a quarter to the negative half, or that's going to be 3 quarters to the negative a half. The negative flips it over the square root, so that's 2 over root 3. Okay, well that's awfully close. Well then let's sub that negative a quarter into part A. That was the expanded version. So that was 1 minus a half of the negative a quarter plus 3/8 of the negative quarter squared. And my calculator is going to tell me an answer 1 plus, that'll come out as plus 1/8 plus 3/8 times the quarter squared. I'm going to leave it as a fraction, 147 over 128. So what that is saying is this 2 over root 3 is roughly the expansion solution. So 1 over root 3, that is a 5. 1 over root 3 is roughly 147 over 256. The question wanted it to 3 sig fig, so I'm actually going to give it as a decimal to 3 sig fig. 2, 3 sig fig. 0.574. One thing I am going to check as well before I move on, another good checking technique, is I'm going to work out in my calculator what 1 over root 3 is. And I'm hoping, yep, it is very, very close. It's 0.577. This is 0.574. So we got very close to our approximation there. Superb. Question 12. The nth term of sequence is that. The sequence is defined by, where u1 is 400, p is a constant. So this is a iterative link. So u2 is going to be p times u1 plus 70, which I could have written nicely the first time. 400p plus 70 is given that u3 is that. Okay, and we need to try and create an equation. So u3 is p times u2 plus 70, and we've been told that's 382. Well, already this is looking quite nice. Here's my quadratic forming. Let's bring the 382 to the other side. Equals 0. There's a common factor of 2, so let's divide through by 2, and we get exactly what they wanted. Okay, next part is given the sequence is decreasing. Well, if this sequence is decreasing, does that just mean that p is negative? Maybe. Find the value of u4 and u5. Well, certainly we're going to have to solve that quadratic first. The 200p squared plus 35p minus, was it 156? 235, 156. So you're certainly going to have to solve this first. Now I could try and factorize that, but that seems like an awful lot of effort. So instead, let's go to our polynomial solver in our calculator, put in the coefficients, negative 156, sorry, and we get our answers of 4/5 or negative 39 over 40. Well, which one of those caused a decreasing sequence? It feels like it should be the negative one, but with these iterative situations you do need to be a little bit careful because it's not always the case. So that negative one might cause a oscillatory sequence rather than a decreasing. So I'm actually going to set up the u1, u2, etc. for each of these just to see which one's increasing and decreasing. We know that U3 in both cases is the 382 and U1 is 400. Yeah, I'm getting more and more feeling that this negative 39 over 41 is going to be a oscillatory one. So with the 4/5, that's 400 times 4/5 plus 70. That gives me 390. If I do it with the negative 39 over 40, that's going to give me negative 320. So we're going to reject that one that's not decreasing. It's going to bouncing between positive and negative. So it's the 0.8 that we're going to use. So I'm going to also cheat a little bit. I'm going to store 400 in my calculator and then do 0.8 times answer plus 70. And each time I hit equals, I'll get a new value. So equals twice gave me the 370 and the 382. Equals again, U4 is 375.6 and U5 is 370.48. Okay, the limit UN as n tends to infinity is L. Write down the equation for L. Well, I could just keep hitting equals and I'll get a guess at that limit. Now, a guess isn't good enough, but we do know that UN plus 1 is equal to 0.8 UN plus 70. So as n tends to infinity, both these are going to turn into L's. UN is going to turn into the L as being the limit, and the UN plus 1 is also going to be that L. So if we solve that, subtract off the 0.8 L and times by 5. Nope. Yep. So that number looked a little too big for a moment until I realized those were the values that we were in the region of anyway. And the limit comes out as 350. And if you do hit equals on your calculator, if you stored the 0.8 answer plus 70, you'll notice that your answer is getting closer and closer to 350, albeit quite slowly, but it's tending towards that value. Question 13. One of the rides at a theme park is a room where the floor and ceiling both move up and down for 10 pi seconds. At time t after the ride, the distance of floor is that, and the distance of ceiling is that. So the initial distance between the floor and ceiling is 8 meters. So when t equals 0, f is, well, 1 minus cos 0, 1 minus cos of 0, cos 0 is just 1, so that's 0. And the ceiling is 8 minus 4 sine 0, sine 0 is 0. That's just 8. So that means that the initial distance between the floor and the ceiling is 8 meters. Okay, now just to check that we understood what the model was talking about. Show that the distance between the floor and the ceiling at any given time is given by that. Okay, so we've got the ceiling and the floor, so we want D to be the ceiling minus the floor. The ceiling was 8 minus 4 sine. Subtract off 1 minus cos. I'm changing my letters all over the place. It was just 1 minus cos, it was. So we need to simplify that into what I call the harmonic form, but the r cos theta plus alpha form. So that becomes 7. I'm going to put them in a slightly different order just to make it look nice. Well, the 7 makes me happy because there's a 7 in the answer. I just need to now turn all of that stuff into the r cos t plus alpha. Well, I want this to be 7 plus r cos t plus alpha. And if I were to expand that out with the addition formula, which you should go and look in the formula booklet if you don't remember them, cos turns into cos sine sine, with the opposite symbol in between. So we had t plus alpha, so it becomes a minus in between. And now just by comparing coefficients, the r cos alpha is the coefficient of cos t, and the r sine alpha is the coefficient of the sine t. And now if I call these equation 1, equation 2 divided by equation 1 gives me tan alpha is 4. So alpha is the tan inverse of 4. Now, looking for some context, is this in degrees or radians? That seems to imply radians. And you should kind of default to radians at this level anyway. So tan inverse of 4 in radians is 1.3258, etc. And to get the r, the trick is to square them and add. So r squared is 17, r is root 17. Now exactly how did they want the answer? Show the distance is given by that. So let's go back to our 7 plus root 17 cos t plus 1.32. I'm going to give it to 3 dp. But I'm going to keep that number in my mind, at least in my calculator, if I need to calculate it with it later on. And actually we don't. That was the end of the question. So that's my pure section done. My applied section now. A particle initially at rest starts to move forward in a straight line with constant acceleration of 6 seconds has a velocity of. This looks like SUVAT. So U, S. Do I have S? I don't have S at all, so I just have the U. Initially at rest. V is our final velocity. The acceleration is what I care about. Time is 6, so V equals U plus AT. 3 equals 6A, so A is a half. It was accelerating, so I do want the positive a half, not a negative a half. And that looks good. A resultant force of that acts on a particle. The acceleration of the particle is that. Well, this is used in our F equals ma. I've written that way too close to the question itself. F equals ma. But in forces, so the F and the A are both vectors. So the force is equal to ma. Using the top row, m is a third to get from -2 to -6. So that's saying that 6 is equal to a third y. So y is 18. Let's make that a little more obvious where those two lines of working came from. Okay, nice and simple. Question 16. A ball initially at rest is dropped to a vertical height of h above the Earth's surface. After 4 seconds, the ball's height above the Earth is 0.2 meters. Assuming air resistance can be ignored, show that. Free fall. Well, free fall is a constant acceleration, so it's a SUVAT setup. Again, we've been told there are 4 seconds. We're told that, well, we're on Earth, so A is just G. Initially at rest, and we've fallen a distance of 0.8 h. We started at height of h and we got to a height of 0.2 h. So now let's just SUVAT on that. S equals ut plus a half at squared, the most common one. 0.8 h is equal to, or 0t, that just disappears. Or write it in because it is a show that question. A half g times 4 squared. So the 4/5 h is equal to 8g. Times that by the 5, divide by the 4, or just use your calculator. It tells you that h is 10g. Assuming air resistance cannot be ignored, explain the effect this will have on the value of h. If air resistance is not ignored, that will imply that this acceleration while we're accelerating downwards, we'll accelerate at a slower rate if there are particles slowing us down. This will imply that A will be, well, it won't be constant, but the important thing is it will be smaller over the whole process. So we're looking for where A was. Well, A is this little bit here, which gave us that term, which gave us that term. And if that's the only thing that's changed, then H will be smaller. A will be non-constant, will be smaller, which will imply that H will be smaller than 10G. And if you think carefully, if we go to a ridiculous situation, if you drop a ball bearing in water where there's a lot of resistance, to make that same distance shift in the same amount of time, you would have had to fall a smaller distance. 16 done. Question 17. A particle is moving in a straight line such that its velocity changes with respect to time shown. Show the acceleration over the first 4 seconds is that. On a velocity time graph, the acceleration is exactly the gradient. So my change in y, this time is my change in velocity, over my change in time, which was 4 seconds, is 3.5 meters per second. Using the fact that acceleration is the change in velocity over time. The particle is initially at a point P. Show the displacement of the particle from P when t equals 9 is that. Now we need to respect displacement. So that's both the positive and the negative. A few different ways we could actually cheat with this, and I am actually going to cheat for these first 4 seconds and use a suvat. So S equals, the initial velocity was -4, the final velocity was 10. The acceleration we know, but I'm going to use the time instead. We know it's constant acceleration because it was a straight line. So that's S equals U plus V over 2 times T, which you will notice is the area of a trapezium, which is, if you think very carefully about the picture, we are kind of working out the area of a trapezium here, even though it's slightly negative. So that's -4 plus 10 over 2 times by 4. That's 6 over 2, that's 12 meters for that first section. And then finally from 4 to 9, I'm not going to do anything too fancy. We know that the displacement is the area. So the area here is the base, which is 5, times the height, which is 10, which is just 50. So the total is the sum of those two, 62 meters. Was to show that, so I have tried to signpost my work as much as possible. Just writing things like that and that for the examiner, rather than just the working where they have to try and guess what you're thinking about, is incredibly helpful to them. Question 17 is done. Question 18, a toy remote control speedboat is launched on one edge of a small pond using a straight line across the surface. The velocity is modelled by that equation. Find the acceleration when t equals 2. Well, here we need to recall that the acceleration is the derivative of velocity with respect to time. If I differentiate that, I get that expression. So when t equals 2, the acceleration is as so, which I am going to check in my calculator, which is -0.08 meters per second squared. Just double check that the units do line up. Okay, find the displacement of the boat from the point it was launched when t equals 2. Well, here displacement is the integral with respect to time. So now I need to try and integrate that v. So that's 0.9t plus increase the power divided by the new power. That cubed, nope, squared, jumping ahead of myself slightly, minus, this one is going to be the cubed term, plus c, but when t equals 0, the displacement is 0, which implies that the c is 0, because we want the displacement from where it was launched. So there's no displacement when you start. And then finally, when t equals 2, the s is equal to, and I'm writing out an awful lot here for it not being a show that question. So 0.18 plus the 0.08 times 2 squared minus the 0.02 times 2 cubed gives me a displacement of 0.34 meters. Does that seem reasonable? In 2 seconds, a boat goes 30 centimeters. It did start at rest. After 2 seconds, it is starting to slow down again. It doesn't seem unreasonable. Seems quite small, but it is quite a small scale situation. So I'm going to, no alarm bells are necessarily ringing too loudly for that one. Question 19. A particle initially rests on a smooth horizontal surface. The resultant force, so it moves in a straight line. Magnitude of the resultant force is just the magnitude of that vector, the 12 squared plus 9 squared, which is square root 225, which is 15. You may have noticed that it's just a 3, 4, 5 triangle, but 3 times bigger. 2 fixed points A and B are position vectors with respect to the origin. P moves in a straight line parallel to AB. Well, let's find the vector AB. Well, the vector AB is OB subtract OA. If you need the kind of visualization for that, if there's O, A, and B, if I want to get from A to B, I need to go backwards along A, forwards along B. So it is that order. So that's going to be K minus 3 and K minus 1 minus 7, K minus 8. Find the value of K. So we've been told that P moves in a straight line parallel to this. But the only thing causing P to move is the resultant force. And if you're parallel, that simply means you are a multiple of. So that means that K minus 3, K minus 8 is a multiple of 12, 9. Now I'm using lambda here. That's more of a habit from further maths. We use lambda in this context a lot. But that means that 12 lambda is K minus 3 and 9 lambda is K minus 8. I'm going to have a quick check that I haven't copied anything with the previous line wrong. K minus 2, K minus 8. Brilliant. This is simultaneous equations. You could use these in your calculator. I'm just going to subtract them, because when I subtract them, I get rid of the k's immediately, and then equation 1 is going to tell me 12 times 5/3 is 20. Tells me that k is 23, and if I do a mental check, that does work in equation 2 as well. So k is just 23, using the fact that parallel vectors are multiples of one another. Question 20, we've got our connected particles, and this is our last question. A rescue van is towing a broken down car. The van and the car move at constant acceleration along a straight road. The van has a mass of 2,780. The car 1,620. The van has a driving force of D newtons. Notice I'm labeling these onto the picture as I read the question, just to develop as much as possible. The van experiences a resistive force that goes backwards of R. The car experiences a resistive force of 0.6 R. The tension in the tow bar, well, that's pulling the car forwards and the van backwards, can be modelled as that thing where K is a constant. Okay, with all these questions, we have a choice on which parts of the system to model. I could try and model the entire thing. If I try and model the entire thing, then the t's cancel. I could just model the car. If I just model the car, that will link t with r. I don't want t in terms of r, I want it in terms of d. If I just model the van, I'll get t in terms of r and d. Well, none of those really work, so it looks like I need to use two of them in combination. So, I think the easiest versions to use is the entire system, that'll link D and R, and then just the car, which will link T and R, and then I can combine them together. So I'm going to look at the combined system first, and I'm telling the examiner that. I'm going to use F equals MA. So my F for the entire system, I've got a forward force of D, and I've got a backward force of the 0.6 R and the R. I don't need to include my forces of T. And that's equal to, now the total mass of the system is 4,400 times by the acceleration. Now I have taken everything forwards to be positive, just double checking that all my signs are correct, and that does work. So that's telling me that D is 1.6 R plus 2640. So I have D in terms of R. I'll probably wanted to write that as R equals rather than D equals, because I want to get rid of the R later. But I can do that when I see the shape of my other equation. So now let's try and include the tow bar in it. Let's look at just the car. Again, F equals ma, T minus 0.6 R is equal to the mass of that thing times acceleration. And yeah, here I'm going to have to try and get the R equals on the other one. So I'm going to rearrange this one first. 0.6 R plus the 972 this time. And from the previous one, this is why I always leave myself a little bit of space. This I can write as R equals, well, 1.6 is 8 over 5. So this is going to be 5/8 D. So I'm dividing by that 1.6 minus the 2,640 divided by 1.6, which is 1,650. So then my T is equal to 0.6 lots of that stuff. And I'm hoping that as I simplify this, I get that, is it negative 18 that I'm expecting in my answer. So this is going to come out as 0.6 times 5/8 is 3/8 minus 0.6 times 1,650 is 990 plus the 972. So therefore, we have that negative 18 we wanted. We wanted to find K, so let's quote K being the negative 3/8. Challenging question there, both with the algebra and be very careful with the connected particles method. State one assumption that should be made in answering part A. So what did we assume here? And we need to be careful not to give an assumption which has already been stated. So for example, the assumption of there is no air resistance is completely invalid because we've been told about total resistive forces. So saying no air resistance is invalid because we've we've modelled that. All of that is in the question itself. So if we can't have no air resistance, modelling as particles isn't really that relevant in this question. But the one thing that we do have to really worry about, that we should state something about, is the tow bar itself. Now, if we read the question very quickly, it doesn't actually give us any assumptions about the tow bar, so that's exactly what the question is implying. We're going to assume the tow bar is rigid, so it doesn't bend, and inextensible, so it doesn't stretch. If you've done physics at GCSE, you might have remember Hooke's law. Hooke's law would have had to come into a question like this if we didn't assume inextensibility. And that was the last question. Of course, if you're in the exam at this point, you should go back and check all of your work, double check all your calculations, fill in any gaps that you might have. But I'm going to end this here. If you have spotted any errors or you have further questions about any of these, please do let me know. Otherwise, have a wonderful rest of your day, and I'll see you in the future.